Hey guys, today we are doing test 2 review for my fluid mechanics test. And we got 3 problems on the board right now. The first one is according to the sign convention, this is number 1, mass flow rate out of a control volume is negative and the mass flow rate in is positive. This is a true or false question. So on the equation sheet they give us this equation. It's called the continuity equation. From this, we can deduce our answer. According to the sign, mass flow rate out is negative. The mass flow rate in is positive. That doesn't look right, so it's false. Number 2, consider a flow given by the vector field V. There's supposed to be an arrow over this. V is equal to x squared y I squared, or I vector, minus x y squared j vector. And part A is it a 2D or a 3D flow? And explain. So this is going to be a 2D flow because first off, there's no W. This is our U, this is our V. And if we had a K, there's no W or K. That would be in the Z dimension. So no, it's not. And then secondly, we don't have a time variable. So if it was x, y, t, it would be 3D. So it is a 2D flow. Is it a steady or unsteady flow? It's a steady flow because, again, we do not have a W or K. So no Z. Is the continuity equation satisfied? Prove using equations. This is the continuity equation for this, and we have to make certain it's equal to 0. So what we do is we take the partial derivative of u and v and add them up. So when you take it, you get 2xy plus negative 2xy. What does that give us? That gives us 0. And, I'll write it. 2xy minus 2xy is equal to 0. So yes, 0 is equal to 0. So it is proven true. So now we're moving on to question 3. Calculate the relative velocity between the cart and the jet. And I got this problem, I did quite well on this test. This is probably the hardest test because that's what they told us, or at least that's what my teacher said. And the only it's not the only thing I got wrong, but apparently when it says the relative velocity between the cart and the jet, it's talking about the jet water. That's what you're trying to find. So to find that, all you need to do is subtract the magnitudes. So what I did is the cart minus the jet. I didn't do this on my test, I got this wrong. Yep. Continuity equation for steady incompressible flow. Yeah, there's multiple continuity equations, or at least on the exam sheet. Let's see. This is test 3, this is test 2. This is test 1. Oh, shoot. Let's go to test 2. So I didn't write down the right answer on this piece of paper, but I know it's C minus, or maybe it's J minus C. Tissue 930. Yes, it is. It's not even the magnitude, so I was wrong on one point. It's not the magnitude because when you're taking the magnitude, that's why I was wrong, because taking the magnitude is turning a vector into a magnitude. So what I'm supposed to do is just cart minus the jet. So the work So we're looking for the work? Well, I guess so. It's equal to 35 meters per second minus 10 meters per second. So our answer is 25 meters per second. And that is what's done on the that's the relative velocity. Okay, now the last question that's multiple choice, well actually I think it's one of the only ones that's multiple choice, is for a fixed control volume on a fluid. Which of the following is the correct vector form of the steady flow linear momentum equation? Okay, I'm gonna write it down real quick. Okay, so this is a difficult one. So this is our linear momentum equation for a fixed non-deforming control volume. It's dt, d over dt, control volume, velocity, density, dv, which is volume, plus control surface, v, density, v times n vector, I think. dA is equal to the summation of the force of the contents. So that's the equation, but really I think what I should have written down is the continuity equation again, because that's what will help you most in this one. And oh shoot, I gotta clean that up, but it's not too bad actually. Is in out minus sum of forces M in is equal to 0. But the only reason why I say that is because on the other equations it says the symbols in bold are vectors. So this is a vector, and oh shoot, this right here is a vector. So for the other equations, the out and the n, one of them was a positive n instead of a negative n, and then the other one was a negative out. So you can just cross those out, and then the only other one didn't even have vectors in the equation. So it's this exact same equation, but these aren't vectors, and you need vectors for the summation. So I think that's how I got it correct. But you know, this is a tough one, so good luck. I think the only reason why I got this right is because on the review, multiple choice, this was one of the things, and I made sure I knew exactly which one. I don't even know how it came into my brain during the test. I was like, this is the right one, you know? But all right, next problem. Okay, guys. So this one is, if water flows at 150 kilograms over seconds through the through the pipe at B. Okay, it says WYE, the double wide, I don't know, but and at 50 kilograms over seconds at C, and 150 kilograms over seconds at S through D. Determine the average velocity of the flow through the pipe at A. Oh, and I forgot to include the diameter. 350 millimeters. They give you other diameters, but those, you know, I got this question wrong actually, because I was thinking this mass flow rate is actually velocity, like meters over second, not kilograms over second. So I did it a whole different way, and I just got it wrong. So first off, for M of A, we gotta figure out what is M of A. Since it's M of A is equal to MB plus MC plus MD. So for that we have all those. So it's 150 plus 50 plus 150. It's equal to 350 kilograms over seconds. So from that we have our mass flow rate. now we need to convert it since we're looking for the velocity. We're not looking for the, we're not looking for anything else. Do I give this equation? Should I have written this one down? No, I don't give this equation. So you have to know this. Oh, wait, no, they do. Okay, so mass flow rate, m dot is equal to density times q. Q is q our mass flow rate? I think q's our mass flow rate. Yeah. Well. No. Yeah. Q is the mass flow rate because that's in meters cubed over seconds. This is in what is m dot? It's kilograms over seconds. What is that called? I don't know. What is kilograms over seconds called? Let me look this up. What is this? Mass flow rate. Yeah. Okay, so, very, very similar. What is meters cubed? What is meters cubed divided by seconds called? No. Volume flow rate. Okay, so mass flow rate, this is the volume flow rate. Okay. And the volume is the area times the velocity. Okay, so we have, this is water, so we know the density, it's 1,000, and the area is, I guess you have to do the math for that, yeah. The area of a circle is pi over 4d squared, so that's equal to pi for 0.35, yeah, squared. So after plugging in, we get V is equal to m dot over density area. So we get 350 kilograms per seconds, 1,000, what is that in? Kilograms over meters cubed, and then just area, which is meters squared, and I'm not writing what it is because I didn't write it. 5 squared. And what you get is VA is equal to 3.64 meters per second. Alright guys, on to the next one. Okay guys, so this is question 6. A velocity field for oil is defined by U equals 3y meters over seconds. V is equal to 0.6 t squared plus 2 meters per second, and t is in seconds, y is in meters. Determine the acceleration, magnitude, and direction of a particle passing through the point 1 meter, 2 meters, 1, 2 meters, 1, 2, and when t equals 2 seconds. So from our equations that we get, that's just magnitude equation, everybody knows that one. But from our AX, we see du dt. There's no t, so we cancel that out. Du dx, well, plus u du dx. That one is canceled out because there's no x, and we're taking partial, so it's 0. V times du dy, that's the only one that's there, and w is 0. From our AY, dv dt, we have that one. U dv over dx, there's no x in our v, so we cancel that out, and plus v dv over dy. Don't have that, and we don't have w either, so all of that's canceled. So what we're left with is ax is equal to v du over dy. Ay is equal to dv over dt. So from that, ax is equal to 0.6 t squared plus 2 times 3. So t is equal to 2. So 0.6 times 4 plus 2 times 3. And what we get from that is yeah, I did this one a little wrong, so I don't have the answer on my paper. Should have written it down. But it is 13.2 meters per second. Ay. So you're supposed to substitute in, and what I did is I multiplied the 3 by it, so I got 1.8 plus times t squared plus 6. And actually, am I right? Because if you do the math, I mean, 4 times 1.8 plus 6. Oh, I know what I did wrong. So I did the math correctly, but instead of adding 6, I added 2. So I got 9.6 instead of... How did I get 9.6? That's a really good question. I don't know how I got 9.6. But whatever. It's probably 1.8 times 2. 2 plus 6. Yeah, it's 1.8 times 2. So I didn't square the 2, which is my fault, honestly. And they only subtracted 1 point, so it's nice. Okay, now we have dv over dt, which is 1 point. I'm gonna need a new marker soon. T plus, oh no, it's just 1.2 t. And when t is equal to 2 seconds, ay is equal to 2.4 meters per second squared. Meters per second squared. Okay, and now we use our magnitude, so it's the square root of 13.2 squared plus 2.4 squared. Not that much of a difference, so what we get is 13.4. But in the original equation, it asks us for the direction. So, doing our tangent equation, it's ay over ax, right? Because it's tangent. Yes, I'm right. Right? Yes, okay. Ay over ax is equal to our theta, and that's our direction. So after doing that, it's just tangent inverse of 2.4 over 13.2, and that's equal to, what is it, 14? No, 10. 10.3 degrees. And that is, I mean, you don't have to do that, but that's what it is. Alright guys, on to the next equation. Alright guys, so this is the next equation. The velocity potential for the horizontal flow is phi, I think that's phi, is equal to x cubed plus 5xy squared meters squared over second. Take density as 925 kilograms over meters cubed, and for A, we're determining the magnitude of the velocity at point A52 meters. B is the flow irrotational, not irrational. Prove using equations. C, find the difference in pressure between this point and the origin. Oh, yeah, that's PA minus PB. So from our equation sheet, we get U is equal to d phi over dx, phi is equal to d phi over dy. So what we get is u is equal to 3x squared plus 5y squared, and v is equal to 10xy. So when we plug in 5 and 2, what we get is 25 times 3, 75 plus, what is 4 times 5? 20, so 20, 95, 50, 100. So 195. Wait, is that right? Oh, I'm sorry. It's not a plus. It's not a plus. It's a minus. I was wondering why it seems so big. It's not a plus, it's a minus. So it's not, it's 75 minus 20. So it's 55. And from doing that, we can just v is equal to this. I'm just going to write it here. We already wrote it down. 114.1 meters over seconds. Okay, on to part B. Okay, so this is the next equation that they give you on the equation sheet. Wz is equal to W, with the line over it, equals 1/2 dv over dx minus du over dy. And if it is equal to 0, it's true, and that means it's irrotational. If it's not equal to 0, it's not true, so it's rotational. So, what we get is dv dx. Oh, I didn't have our v. Our v is negative 10xy. Our u is 3x squared minus 5y squared. So our dv dx is negative 10y minus negative 10y. So it's 0 equals 0, so it's true. So that means it's irrotational. Not rotational, irrotational. Next question. Okay, part C. Finding the difference in pressure between point A, which is 5,2, and point B, which is 0, 0. So from our u and v equations, u is equal to 3x squared minus 5y squared. Our v is 0, 0. So that's 0. So our u is 0. Our v is going to be 0. So the magnitude of the velocity is 0. So v of b is equal to 0. So from that, we can figure out the pressure difference, because this is the specific gravity of water, and we're working in meters squared. Oh, we have the new density. It's 925 times gravity. So 925, what's that, kilogram meters cubed, 9.81 meters over second squared times 0 minus 114.1 squared meters squared over second squared. G is 9.81 again. 1 meters squared second squared. No, just meters. Just meters. And what we get from that equation, if we plug it in, is 600. Is that 6 million? Yeah. No. Yes. Yes. 6,021,119 0.63 pascals. Because if we're just working base components, it becomes pascals. So reducing it, it's 6,021 because if you divide by 1,000, 0.2 kilopascals. Alright guys, that is the difference in pressure. Next question. Hi guys, this is problem 8, and the pump shown in the figure adds 4 horsepower to the water and produces a velocity of 3 feet per second through the pipe at A. The frictional head loss within the system is 8 feet. Write the energy equation. This is the energy equation, and make simplifications in indicating all the assumptions made. So that's part A. We're going to do part A first. So, first off, it's at the same height in Z, so we're just going to cancel those. We have HL, but we don't have HS. To find HS, we have the W shaft, the work of the shaft N, net N. So the equation for that to get the HL is the work divided by the specific gravity times the volumetric flow. And 1 horsepower is equal to 550 feet per pound seconds. 550, so 4 times 550 is equal to 2,200, and this is in feet, pound, over seconds, right? Yeah. But pretty much all we need to do is do the algebra for this equation. So we're looking for the part B is determine the difference in water pressure between B and A, give the answer in PSI. So we're looking for B minus A, yeah. So PB minus PA is move that, so VA squared minus VB squared over 2G plus HS minus HL. Oh yeah, 2,200 over 62.4. We're working in feet, so 62.4. That's pounds over feet cubed. Feet, pound, second, and then Q is, what is Q? Oh, Q1 is equal to Q2, but all that's equal to V times A. So the velocity is 3 feet per second times our D for A, which is pi over 4, 0.75 squared. And that is equal to, oh yeah, we're looking for V, we have VB, VA, so we're looking for VB, and don't we also, yeah, we're also looking for Q1. So Q1 is equal to 1.325 feet cubed over second, or QA. Should keep my dimensions homogeneous. So V of 2 is equal to, since Q1 is equal to QB, wait a minute. I think I did it wrong, because for V1, A1, I used 0.5, but that's for VB. So maybe I was wrong, and they didn't take off points for it. how did I get the right answer even though I did it wrong? That's funny. Oh, nah, that's funny. So I wrote 0.5, but I did 0.75, and then 1.325 divided by pi over 4, 0.5 squared is equal to 6.75 feet per second. So that's VB. Okay, so now after doing that, we plug in our stuff. So, oh yeah, almost forgot about specific gravity, because once you get everything to one side, you have to get this P beta minus PA by itself. So 62.4 times 3 squared minus 6.75 squared over 2 times 32.2 plus HS. Oh, 1.325. Okay, and once we do that, it's equal to HL is 26.6 feet. That's funny. That's pretty funny. So HX is 26.6 minus 8, and then once we all do that, it's 1125.2 pounds over feet squared. And since it's in pounds over feet squared, we divide by 144. Or, yeah. Is equal to 7.81 psi. Alright guys, that is part A and part B. I hope you all enjoyed. Now on to part 9. Okay guys, so problem 9. Crude oil flows through the horizontal tapered 45-degree elbow at 0.022 meters cubed per second. The pressure at point A is 375 kilopascal, and the pressure at B is 8.3 kilopascals. The density of the oil is 870 kilograms per meters cubed. Neglect the size of the elbow. Part A. Draw a diagram of the control volume. Show velocities and forces acting on the control volume. So right here, I already started, but we have A, we have B, we have the same thing. We have the diameters right here. We have the volume flow. We have the angles. You don't really need the angles except for one specific point, but still I'm going to not write them on the diagram, on the force diagram. So obviously we have the velocity at A and the velocity at B. But for fluid forces, we also have to do the pressure times the area, because that gives us another force. So we got AA, and then we have, when you have a fluid velocity going out, for some reason, the force of the pressure, the force of the force acting on it is going in the opposite direction, because when it's angled like that, I mean, when you're shooting a hose, it comes out the hose. If you let go, the hose comes backward. So our other pressure is PB/AB going into the thing, which is really an interesting, just an interesting little bit, you know? Because who figured that out, you know? Who's like, oh, this hose travels backwards, so the pressure times the area must give it, you know? And pascals are in newtons over meters squared, I'm pretty sure. Right. And that's why if you multiply by the area, it gives the stuff. So then all we have to do is part B is determine the horizontal and vertical components of the force required to hold the elbow in place. So Fx and F, we don't really have a y. No, we don't have an Fy. No, we do. We definitely do. So Fx, this is going to take a lot of room, and I kind of use too much. So Fx is equal to, or well, I'll just do this. So VBX sine of 45, because when you have the VB, it's acting on it towards sine, and sine is, we're looking for the vertical, wait, what? We're looking for the horizontal. So if you have a sine triangle, sine is SOHCAHTOA, so opposite over adjacent. So we're looking for this one. We're looking for this line. So opposite over or hypotenuse. That's the hypotenuse. Yeah, I'm right. It's cosine. How did I get it right? Oh, I get why I got it right. Sine of 45 and cosine of 45 degrees is the same when you plug in 45 degrees to it. You get square root of 2 over 2, or whatever, and it's the same exact number. So it's not sine, it's cosine. I was so confused by that. And then you multiply that by the mass flow rate, which is negative m dot n, because m out minus mn, right? Let me go to my equation sheet real quick. Yeah, m out minus mn. Okay. So, and then we have that equal 2f of x minus PB, PA. Wait, what? Oh. Never mind. Minus PA, plus PB, sine. I did sine again? No, oh my gosh, I'm dyslexic. Ah. I swear, dude, some of these times I'm like, oh, looking at the right thing, and then I look at the wrong thing. It's minus PB, AB, cosine of 45 degrees. Stop looking at the wrong thing. So the reason why that is, it's because for the directions, the PA, AA, and the VA are only acting in the Y direction, and PAB, AB, and VB are the only ones acting in that direction. So 0.71, 0.71, and then PBPA is 8.3 times, well, 8,300 times, oh yeah, I should probably write down the diameter. It's funny, I wrote it down. we need to solve for VA and VB. So Q, we don't really need another Q. Q is equal to 0.022 meters cubed over second, and Q1 is equal to Q2. So VA is equal to that number, 0.022 over pi for 0.05, because point A is 50 millimeters and point B is 30 millimeters. Okay, so from that we get 11.2 meters per second and 31.1 meters per second. And then the mass flow rate is, not the volume flow rate, is m dot times Q, which is the density is right here, 870 times 0.022, which is equal to 19.14 kilograms over seconds. Now the reason why is why is that? How is VA times VB? I mean, how is the velocity times that? Oh, it's because it's already over seconds. Okay, so the reason why the VB times the mass flow rate is because newtons are kilograms times meters over seconds squared. So now we have our VB, and our VBX is just 0.71 times 31.1. And then the mass flow rate out, which is equal to, it's equal to the one in, yeah. But it's negative, so negative. Oh wait, no, this is the out, because we're doing VB, we're not doing VA. Sorry about that, but it's not negative. It's 19.14. It's equal to Fx minus PB is 8.3, so once you do the math on that, the pi over 4 times 0.03 times I keep looking at the wrong thing. 8,300 times pi over 4, 0.03 squared. Oh yeah, times cosine 0.01. So Fx is minus 4.17 time equals 422.63. So Fx is equal to 426.8 newtons. Okay, so that's Fx. And that's all the things acting in the x direction. Now all we gotta do is Fy, which has a lot more, but it's still pretty much sum of forces. So negative VAN, well, yeah, okay, so this is just straight vertical. So negative M, N, so these are multiplied. And then we have the B cosine of 45 times M dot out, and it's equal to Fy minus PA AA plus PB AB sine of 45, which which is 0.71. And doing all this, we get an Fy, because the Mn is equal to M out, the Va is just 11.2, Mn is 19.14, Vb is 31, 0.71. It's not cosine, it's sine. But it doesn't really matter. But anyway, in dot out, 19.14, and from doing all that, oh yeah, and PA is 375 kilopascals, so that's 300,775 K times an area of pi over 4, 0.05 squared. Okay, and then that's that, and then plus what we did last time, which is 8,300 times 0.pi over 4, 0.03 squared. But pretty much in the end, we get 523.88 newtons. We don't get kilonewtons, we get newtons. Alright guys, that is, I'll do some of the math for you. 214.4 minus 422.63. I mean, that's what we got last time. And then minus 736.3 plus 4.17. Since it's negative, it's gonna add up to, oh yeah, this becomes a negative 200 plus 700 plus, this is 4.17, yeah, I wrote that. It just equals 500. Alright guys, that is all for test 2. That's great. Hope y'all enjoyed. I will see y'all in the next test 3 video. Bye bye.